Good morning, guys. Today we're going to be talking about factoring special products, and this is going to be part one. And just to make sure we're on the right notes, we're on 2.03. And our goal today is to be able to identify and factor uh, these special products called the difference of two squares and perfect square trinomials. Okay, so let's go over some terms when we use the word factors and products, for example. Uh, this first term here, factoring, is the reverse process of multiplying given a certain product. Okay, and so if I ask you, for example, what are the factors of the product 12? Well, some factors you can say are 1 times 12, or 1 and 12, or you can say 2 and 6, and 3 and 4. So these are all possible factors of the product of 12. Okay. Um, and so if you think of it, it's factoring is the reverse process. So you're breaking up 12 into its parts that can be multiplied to give you 12. Now, if we take that in an algebraic sense, instead of working with numbers, if we look at an algebraic equation, if I give you, for example, this product, and let me kind of outline it so you know what I'm talking about. If I give you this product, I can ask you, can I factor this? Can I factor x squared plus 4x plus 3? And if I can, then these two items here are my factors. And this actually, since it's made up of three terms, this is called a trinomial. The prefix tri means three, right? So there's three terms, trinomial. This one also is a trinomial. And if there are two terms, it's called a binomial. Okay, so it's just a kind of a side note, right? So we said this is a trinomial, and this is a binomial, because there's two terms, three terms. Okay. So the special product that we're going to be looking at is called the difference of squares and the perfect square trinomial. And if we can identify them, then it'll save a lot of time trying to figure out how to factor them. So for the first couple of examples, we're going to practice, identifying whether we have a difference of two squares or a perfect square trinomial. And once we are able to identify what we have, then we can go through the steps of factoring. Okay, so a couple of things about the terms that we're using. For example, I use the term perfect square. So a perfect square is a number whose square root is a whole number, and or a variable with an even exponent. All right, some examples of perfect squares are 1, 4, 9. And keep in mind, these are all numbers that I can take the square root of and get a whole number, right? So as far as numbers go, we can kind of, keep these in our memory. And so if we see them in the equations and expressions that we see, we can say, hey, that's 16 is a perfect square. 81 is a perfect square. Okay? And then if we're looking at variables, then we're only interested in is the exponent an even number? So an even exponent, right? Like 2, 4, 6, 8, 10. If it's even, then we should be able to factor it, and we should say it's a perfect square. Okay. Now let's go to the first special product we're going to look at is the difference of two squares. And so if we break this up, we know that in math terms, right, when we use the word difference, this means subtraction, that there's subtraction going on. And then when we're talking about two squares, it means that the first term and the last term are perfect squares. So if we break it up, right, that's what it means. So when these first couple examples, it's just telling us to state whether the algebraic expression is the difference of two squares or not. Does it fall in this category? Right? Is it made up of two terms? Is there subtraction going on? And are those two terms, the first and the last one, are they perfect squares? Okay, so let's look at the first example. And first of all, is there subtraction going on? So the first question is there subtraction going on? If the answer is yes, then we got the first part checked off. Now the second part is, are these two terms perfect squares? Are the two terms a perfect square? Sorry, let me use black. And so my question is, can I square root this? Can I square root 4? Let's look at the number first, right? Can I square root 4 and get a whole number? Yes. Check mark. What about x squared? Remember on the previous page, if the exponent is even, then that means that this is a perfect square. So another check mark. So there's subtraction going on. The last term is a perfect square. 4 is a perfect square. And the first term, x squared, is a perfect square. So we're going to say that we have that this is a difference of two squares. This is my answer. Because we're just identifying if it is a perfect square or if it's not. All right. Let's look at the next one. And so first check, is there subtraction going on? Yes. Then I like to check the last term first, because usually the last term is a number. And so the number is 25, and my question is 25 a perfect square? Can I take the square root and get a whole number? The square root of 25 is 5. Yes, perfect square. Now, what about the first term, 8a to the fourth. Well, is the exponent even? Yes. But can I take the square root of 8? Because there's a number there. Can I take the square root of 8 and get a whole number? Can I take the square root of 8 and get a whole number? And so I would say this is not a perfect square. So because of that, I'm going to say not a difference of squares. I'm just going to abbreviate, right? So I'm going to say it's not a difference of squares because of that 8. So everything checked off except that 8. Because of that, it's not a difference of squares. Okay, next thing, is there subtraction going on? Yes. I have a 1. Can I take the square root of 1 and get a whole number? Yes. And then I have 36v to the fourth. The exponent is even, so that's a perfect square. Can I take the square root of 36? Actually, let me do that on the side over here. Can I take the square root of 36? Yes. So everything checks off. So that means we have, this is a difference of 2 squares. All right, let's go to the next example. The next example, we're actually going to start factoring. All right, so there's a couple of steps, and the idea here is if we can identify that what we're working with is a difference of squares, then we can break it up into the following factors. So if I know what the first term is and the last term, then I can break it up in the following way. So my first step is to check to see if the algebraic expression is a difference of 2 squares. So that's what we did in examples 1, 2, and 3, kind of practicing the process of checking. And then it says find the square root of the first term and the last term, write the 2 factors according to the pattern above, and then you can check your answer by multiplying. Okay. So let me see if I can put the steps in the view. Yeah, okay. So let's do what we were doing in the previous examples, and what we want to check for is, again, is there subtraction going on? Yes. X squared is even. It's an even exponent, so that checks off. And then can I take the square root of 16 and get a whole number? Yes, right? So everything checks off. So step 1, checked off. Step 2, find the square root of the first and the last term. Okay, so I already found the square root of the last term. I just need to find the square root of the first term. So that's the question. What's the square root of x squared? Well, we would say that the square root and the square cancel. And so if they cancel, I am left with x. Okay, and so we want to think about the first term that we got. If we compare it to the equation up here, then this is like our a, and this is like our b. And so if we set it up, we have 2 parentheses, just like up here, they have 2 parentheses. And so we're going to do a plus b. But what is a? A is x, and b is 4. So we're going to do x plus 4 in the first parentheses, right? A plus b. And then in the second parentheses, we're going to do a minus b. A minus b. So it's going to be x minus 4. And that's our answer. We can check it. So far, all right, this is my answer. Let's check it. So if I check it, we have to, I'm trying to decide what color to use. I'll just use red. So if we check it, we multiply it out, and we get x squared. Right, x times x is x squared. X times negative 4 is negative 4x. And then I use purple, and so we multiply the 4 out. And so what's 4 times x? 4x. And what's 4 times negative 4? Negative 16. What happens to these two? What's negative 4 plus 4x? Negative 4x plus 4x. These will cancel. And so I'm left with x squared minus 16. So isn't that the original equation? Yes. And what did we do? All we did was we square rooted the 16 and square rooted the x squared, and then just use this kind of template, right? All right, let's practice it again. And practice it again. And I'm going to put the template up here. It's a squared minus b squared equals a plus b and times a minus b. Okay, so I'm just copying what's at the top of the page just so that we can have it next to the example that we're working on. Okay, so is there subtraction? Yes. Can I take the square root of the first term? The first term is 9m squared, and the last term is n squared. But can I take the square root of these? Yeah, is the exponent even? Yes. Is this exponent even? Yes. Can I take the square root of 9? Yes, the square root of 9 is 3. Okay. Step 2 says to square root the first and the last term. So let's square root it. What's the square root of 9? 3. What's the square root of m squared? M. And let's look at the second one. What's the square root of n squared? Square root and the square will cancel. So that is n. Okay. So this first term, this is like my a. And the second one is like my b. And so if I follow this format, I'm going to set up 2 parentheses, 1, 2, and the first parentheses is going to have a plus b, a plus b, a plus b. So my a is 3m and my b is n. So I'm going to do 3m plus n, 3m plus n. So let me write it up here. We want to do a plus b and a minus b. But my a is 3m and my b is n. So 3m plus n, and then 3m minus n. Alright, so I'm going to erase this blue part up here. But that should be my answer right here, what I wrote in the 2 parentheses. Can we check it? Yes, definitely. Let's check it. Check it. So we're going to multiply 3m times 3m and 3m times n times negative n. So that's going to give me 3m times 3m is 9m squared. 3m times negative n is negative 3mn. And then multiply n times 3m and n times negative n. So that's going to give me plus 3m plus 3mn minus what's n times n? N squared. Now, what's going to happen with these two? You should see that they're going to cancel. And so I'm going to be left with 9m squared minus n squared. 9m squared minus n squared. But isn't this the original problem that was on the paper? Yes. So we're just checking it, right? But all we're doing is we're following this template. Just following that template. All right, let's go to the next example. So again, I'm going to write the template up here. It says that a squared minus b squared equals a plus b and a minus b. Okay. There's subtraction going on, so that's a check mark. Then we ask ourselves, we can do a quick check, right? Can I take the square root of 36 and get a whole number? Yes. Is the exponent even? Yes. So we got 2 checks right there. And then 25n squared. Can I take the square root of 25 and get a whole number? Yes. Is the exponent even? Yes. So everything checks off. So then step 2 says to square root the first and the last term. So let's square root the first one. What's the square root of 36? 6. What's the square root of m to the 4th? What's the square root of m to the 4th? That's going to give me m squared. So what the square root does is it divides the exponent in half. Okay, so if the exponent was 4, what's half of 4? That's 2. Okay, the next one is, what's the square root of 25? It's 5, right? And then what's the square root of n squared? Well, what's half of 2? That's 1, so it's going to be n to the 1 power. So this is going to be my a, and this is going to be my b. And so we're going to set it up in the following way, right? And so the first parentheses has to have a plus b. A plus b. So this one plus this one. This one plus this one. Okay, so it's going to be 6m squared plus 5n. And then the second parentheses is going to be a minus b. A minus b. So this one, the first one minus the second one. So 6m squared minus 5n. Okay, so that's kind of the pattern, right? It's going to be first plus the last in the first parentheses. It's going to be first expression plus the second, and then the first minus the second. Oh, I almost forgot, but in the beginning, and the way I'm recording, I can't go back. If I go back, it's not going to take the video back. But if it's not a special product, if it's not a difference of squares, and we can't factor it, we call it prime. Okay. The reason I mention it is if I'm looking at this one and I look at it, is there subtraction going on? No, right? Is there subtraction going on? No. So just by that alone, it's not a difference of squares. It's not a difference of squares. Even though if you would have looked at it and you would have said, oh, x squared, the exponent is even, check, right? Then you would have looked at 4y squared. You would have said, the exponent is even. I can take the square root of 4 and get a whole number. So I have check, check. But since there's no subtraction going on, then we can't factor it. We can't use the rule that we've been using. The rule only works if we have subtraction and if we have perfect squares. That's why it's called difference of squares. So we would say, we call this one, we call it prime. And what prime means is that it cannot be factored. So when I say that something is prime, when an expression is prime, basically what I'm saying is that it cannot be factored. Okay, so for this one, example 7 is prime. Example 8. Is there subtraction going on? Yes. Can I take the square root of 1 and get a whole number? Yes, right? And then the last term, 100 n to the 4th. Can I take the square root of 100 and get a whole number? Yes. Is the exponent even? Yes. So everything checks off. And so the next step is to square root the first term and the last term. But I already square rooted the 1. I got a 1, right? Now what do I get if I square root the second term? Sorry. What do I get if I square root the second term? So what's the square root of 100? That's 10. What's the square root of n to the 4th? Remember, what the square root does is that it divides the exponent in half. So what's half of 4? It's 2. So it's n to the second power. Okay, so this is my A, and this is my B. And so remember, we have to do A plus B, parentheses, A minus B. All right. So I'm gonna do. I'm sorry about that. I spaced it out wrong. So we're gonna do a plus b in the first parentheses and a minus b in the second parentheses. That looks better. Okay, so in the first parentheses, we're going to do a plus b. So what I circled first plus what I circled second. So it's going to be 1 plus 10n squared, and then 1 minus 10n squared. And that should be my answer. And again, feel free to pause the video at any point. All right, the second special product that we're going to be talking about is, or looking at, is the perfect square trinomials. And let's read. For an algebraic expression to be a perfect square trinomial, the first and the last terms must be perfect squares. Okay. So the first and the last term must be perfect squares. So kind of like what we were looking at in the examples that we worked out previously. Okay. The only difference is, since it's called a trinomial, remember trinomial means that there's 3 terms. There's 3 terms. Right? So we have a first, a last, and a middle. And what we want to check for is that the first and the last terms are perfect squares. So kind of like what we were doing in the previous example. So the first and the last terms have to be perfect squares. So in other words, I can take the square root of them. So I just put a square root symbol right here. So the only addition that we're changing here is that the middle term must be equal to twice the square root of the first term and the last term. Okay. And remember, when we would take the square roots, we would call them a and b. So to kind of simplify what's happening right here in the middle, let me use, I'm trying to figure out what color to use. So let me just use green. No. I'll use blue. It's fine. Middle term. So for the middle term, we want to make sure that it's twice the square root of the first term times the square root of the last term. Sorry. So what that's saying is that the middle term must equal to 2, because it says twice. Right, it says twice here. 2 times a times b. Okay. And so that'll make sense, but keep that in mind. We're going to practice it on the next page. So on the next page, it's asking us to identify if we have a perfect square trinomial. So trinomial means 3 terms. Do we have 3 terms? Yes. And it says we have to check if the first term if I can take the square root of the first term, yes, yeah, can I take the square root of 16? That's 4. can I take the square root of y squared? Yes, right, that's y. And then, can I take the square root of the last term? The last term is 25. What's the square root of 25? It's 5. Okay, so we got a check and a check. Sorry, check mark and a check mark. We could square root the first term and the last term. Okay. Then the second thing we have to check for is if the middle term, so let me circle the middle term, is that equal to, so is 40y, is that equal to 2 times a times b? So remember, in the difference of squares, we called this one a and this one b. Right, you guys remember that? Yeah? So we're going to check that. So what do I get if I multiply 2 times a times b? Right, this is a and this is b. What is that equal to? What's 2 times 4? 8. What's 8 times 5? 40. Bring over the y. Yeah, so does it match up? Is the middle term equal to 40y? Yes. So we got everything checked off. So we would say that this is a perfect square trinomial. All right, let's go to the next one. And so let's look at the first term. Can I take the square root of these? Square root of 64 is 8. The square root of p squared is p. And then let's look at the last one is 1. Can I take the square root of 1? Yes. So this is like my a and my b. And then I want to check what do I get? What do I get if I do 2 times a times b? I want to see if I'm going to get the middle term. So what's 2 times a times b? What's 2 times 8? 16p. 16p times 1. 16p. Is that the middle term? Yes, right? This is the middle term. So check marks all around. Right? I could take the square root of the first and the last term, and I get the middle term when I multiply 2 times a times b. So here we have a perfect square trinomial. All right, let's go to example 11. All right, first first term, can I take the square root of 1? Yes, it's 1. Can I take the square root of 36v to the 4th? The square root of 36 is 6. The square root of v to the 4th, remember the square root divides the exponent in half, so half of 4 is 2. So I got 2 check marks here. The next thing, we're going to say that this first term is a, and the second one is b. And I want to check what I get if I do 2 times a times b. So what's 2 times 1 times 6v squared? Um, 2 times 1 is 2. 2 times 6 is 12. So I get 12v squared. Does that match? No match. It doesn't match, right? This doesn't match the middle term here. So because these two don't match, then this is not a perfect square trinomial. So it's not a perfect square trinomial. All right. Let's go to the actual factoring examples. And so the first step says check to see if the algebraic expression is a perfect square trinomial. So what we were checking for in the previous examples we did. Double the product of the square root of the first term and the last term. Check to see if that answer is the middle term. So again, this is the same thing we were doing. The first two steps is what we were doing in examples, what was it, 9, 10, and 11. And then step 3, find the square root of the first term and the last term, and write the two factors according to the pattern above. And then you may check your answer by multiplying the factors. Now, the checking part, we're not always going to check it unless you're not sure about your answer. If you're not sure, then go ahead and check it, and you can check it by multiplying. But I do want to make sure that in the notes that we check it, just so that we can see that this pattern is working. Okay, and so if you notice, the pattern changes from what we were doing for the difference of squares. The pattern now says, okay, if I have a plus and a plus, then both terms in the parentheses are going to have 2 pluses. If I have a minus in the middle and a plus at the end, then it's going to be both minuses. So if I have a plus in the middle and a plus at the end, it's both plus. If I have a minus and a plus, it's both minus. Okay, so I know this might seem confusing, but once we get the examples rolling, it should all make sense. Oh, and this is what I was talking about in the previous examples. If you cannot factor something, then you write the word prime. Okay, so um, we want to check for, can we square root the first term? What's the square root of x squared? It's going to be x. So yeah, yes, I can square root. In other words, right, the exponent was even. And then, can I square root the last term? 36. What's the square root of 36? That's 6. Okay, so yes, I can. I'm going to put a check mark there. And so this is my A and my B. And so I want to check, what do I get if I multiply 2 times A times B? So 2 times x times 6. 2 times x is 2x. 2x times 6 is 12x. Does it match the middle term? Yes, right? So check mark. Okay. Now, let's see if I can zoom out here. Which pattern does this follow? Example 12. I have a plus and a plus. So should I follow the first example or the second pattern? Should I follow the first pattern or the second pattern? Right? Do I have plus plus or minus plus? Since I have plus plus, I'm going to follow the first pattern. And so the first pattern says A plus B, A plus B. Okay, so, is going to equal to A plus B, A plus B. All right, so keep that in mind, A plus B, A plus B. But we already found A and B, didn't we? So it's going to be x plus 6x plus 6. But isn't something times itself, isn't that squared? Can I write it as x plus 6 squared? Yes. So this is my answer. And like I said, we're going to check it. We're going to check that answer to see if I get back the original problem. So x plus 6 times x plus 6, what does that give me? So we're going to multiply x times x and x times 6. So what's x times x? That's x squared. What's x times 6? 6x. And then we're going to multiply 6 times x and 6 times 6. What's 6 times x? It's 6x, right? And what's 6 times 6? It's 36. Okay. What happens here and here? What's 6x plus 6x? That's 12x. So my final answer is going to be x squared plus 12x plus 36. Does this match the original equation? Yes. Okay. Right. So again, I'm not going to check the rest of the examples, you can check them on your own time, or you can also check them in case you're not sure if your answer is correct. You can always multiply it out, using the FOIL method, to check to see if I multiply my answer, do I get back the original problem? Okay. So for 13 and 14, I'm not going to check. And so let's check it out. Let's look at the first term. Can I take the square root of the first term? What's the square root of 4? That's 2. What's the square root of m squared? It's m. And then the last term, sorry, let me write it up here. The last term is 9. Can I take the square root of 9? Yes, that's 3. So this is like my A and my B. And so I'm going to check. So far I got checks on the first 2 steps. Okay. The next thing I'm going to check for is, what do I get if I multiply 2 times A times B? Is that going to equal to the middle term? Is that going to equal to 12m? So let's check. What's 2 times 2m times 3? 2 times 2 is 4. 4 times 3 is 12 with an m. So I get 12m. Does that match the middle term? Yes. So I got all check marks all around. All right. So at the top of the page, you want to ask yourself the same question again. Which pattern should I follow? Do I have a plus plus pattern or a minus plus? So it looks like I have a plus 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 plus. So that means my answer is going to be a plus b times a plus b. A plus b times a plus b. A plus b times a plus b. So this is going to equal to but we're going to replace this, right? We're going to say a plus b. But what was a? A was 2m, b was 3. So it's going to be 2m plus 3. And same thing over here. So I delete this. And it's going to be 2m plus 3. So that's my answer. So you can keep it like that, or you can say, I can rewrite it as 2m plus 3 to the second power. Both answers are okay. All right, and then the last example. For the last example, we're going to check, can I take the square root of 1? Yes, it's 1. Can I take the square root of 16 n squared? Square root of 16 is 4. The square root of n squared is n. So that's my A and my B. But I need to check, what do I get if I multiply 2 times A times b. What's 2 times 1 times 4n? 2 times 1 is 2. 2 times 4 is 8. 8n. So I could square root the first one, I could square root the last one, and this matches the middle term, 8n. And then the last thing I want to check is, if I zoom out again, I want to ask myself, which pattern should I follow? Is it a plus plus situation or a minus plus? And so this one's different. This one is a minus plus, minus plus. So I'm going to follow the second pattern, which says my answer is a minus b times a minus b. Or you can say it's a minus b squared. So I got my a, I got my b. And so I'm just going to write my answer. And so it's going to equal, it's going to equal to a minus b times a minus b. Or you could say it's a minus b squared. So you could say, you could write it this way, as this is your answer, or this way. Alright guys, well, thank you for joining me. I know this video was kind of long, but again, you can fast forward, you can pause, you can go back, and again, I'm going to be answering any questions you have during the class time, next class, and so feel free to ask me anything during that time as well. But have a great day, guys, and thank you for joining me.